Hello, everybody, and happy Friday. Today, we'll be probably applying the new layout algorithm recursively finally. Yesterday, during my evening session, I made some progress in proving that the new layout algorithm would be good for positioning icons yet again. It looks like it is a feasible candidate for the positioning purposes. I ran into a number of obstacles yesterday, but those seem to be resolved today. So without any further ado, let's dive into the code. I'm pretty excited for today's session. This is how the new algorithm produces the familiar diagram number 1, and this is how it produces the familiar diagram number 2, with also the familiar issues. But that's not the point of today's session. Let's go back to the main file. Oh, sorry. Here it is. So I compressed the main file into this sequential execution of find a new parent, get all its left-hand side dependents. So today I would like to fold all these executions into just one recursive invocation. It should be a pretty interesting session. Stick with me. So what seems to happen in every iteration is two things, I believe. The first one is that we find the parent of a new subtree. We turn it into a positioned icon, and then we generate its dependence. So we have this function first path and first path prime. Remove this. So first path, let's leave alone. In the meantime, what I would like to do is to implement the combination of this function, first to contain unpositioned dependence, and also new dependence. So something like this. This will have to repeat in every iteration. So say we want to introduce this, let's say here. So we'll have to come up with a function which takes a list of positioned icons. And for now, let's say it just returns the pool. I don't really have a good idea of what this function should ultimately return, but for now, I don't really care. Until I see all the pieces together, I don't really know /care. So here, because this is a layout engine, we don't need to use the module name. If this is nothing, we don't know what to return yet. But if it's just parent, do. And this is where I spotted a problem yesterday. The new x cannot be the parent plus the space separating the parent from its next dependent x-axis wise. It needs to be, instead of the parent x coordinate, it has to be the last used x coordinate, not necessarily the parent, but the last coordinate of the last used column, plus icon width and plus space between icons x. But we'll get to that. Here, because it's a pure function, I cannot use the do notation, so we'll have to figure out something else. So for now, let's not make it recursive. Let's just combine these two operations into one, and we'll apply it 3 or 4 times, just as we did here. And then we'll fold those 4 invocations into just one, hopefully. Hopefully I can do this today. So the parent we do have, now we'll have to provide a collection or list of icons. And the new x So here, the return type emerges. It has to be the same type as what is returned by first path prime. And this is positioned icons, or a list of positioned icons instead of just bool. So here we can just remove that. Perfect. So if we do not find any positioned icon which contains unpositioned dependents, we simply return an empty list. Otherwise, we create the first path starting from the found parent. Now the infamous module definition. All will be cleaned. Do not worry. So For now, I think it would be safe for us to just comment out all these lines. Or just cut them. Now we're taking a leap. And XYZ we call with positioned icons, all icons, and new X. Positioned icons, icons, which is also used here, and new X. And in our case, let's just hard code this to for now it should be fine. Later on we'll figure out something smarter. So this will be new dependence. And from this moment on, we do not have access to new dependence prime and new dependence prime, or whatever, however you read it. So we'll need to remove it. So now I'm just expecting to see 2 columns produced by this algorithm, but this should be fine. And I modified the run script to run both diagrams. Okay. Line 52. Oh, here. Okay, so let's see what this produced. 2 columns, perfect. And this should not really change. And it hasn't changed. Okay, so it means that we can start thinking of applying XYZ recursively, which is a little bit scary. So, you know what, call me chicken. But I think what I'm going to do now is I'm going to produce a new list of dependence prime, and I will call it with positioned icons plus new dependence that we got previously. Plus this. Just to check if the 3rd column will be rendered correctly. And it looks like we have a little bit of a hiccup here, line 120. Oh goodness, sorry about that. This shouldn't change, but this one should get another column. And it did. Perfect. So this is the proof that however we defined XYZ might be applied recursively. All right. So in the layout engine, here after we define the first path, let's append to it an application of XYZ again. So this is how the first path works, and it returns new dependents. So in order to call XYZ again, we will need to keep in mind that the positioned icons collection will grow. Namely, with the result of first path prime. So let's do this. Let new dependence equals this in new dependence here I have to be very careful not to have too many items in the positioned icons collection. So this function would change. Instead of returning nothing, it would just return positioned icons. And every time we get a just from here, we'll be just appending new dependents. Why did I write new parents? New dependents. And XYZ needs to be called with positioned icons, which is now positioned icons plus new dependents, I believe. Let's double check. Yes. The collection of icons is not changing. New X needs to change by icon width and space between icons X. And just to keep it human readable, let's use excessive brackets. HLint will probably tell me not to use that many, but we can optimize that later. And finally, main also takes, oh no, nothing more. It's just positioned icons, and new X. This is scary. Let's see if this builds. Typo. Looks like it does build. So now let's think how we could harmlessly apply XYZ here and replace this and this invocation. So now we have, instead of these, refreshed positioned icons will have to be layout engine, defined like this. Layout engine, XYZ, currently positioned icons plus not plus icons and new X, which is icon with space between icons, obviously prefixed with module name. I think we have a good chance of actually running it. It does build, or at least it looks like it will build. Let's run it. It did run. Let's refresh it. I don't want to refresh it yet. Just what I'm expecting to see is once I refresh it, we should see all 4 columns. And we do. But I can already see that the lines are pretty thick, so they must be rendered multiple times. It's not great, but we can check what's going on in a second. Here, though, I'm expecting no changes. Oh, as you can see, the lines got a little bit thicker. I'm not sure if you can see it where you're watching it, but they got thickened. All right. Now, so this is promising, however, not without any issues. Let's then try to print all positioned icons. Print. This will probably reveal a lot of noise. Yes. So this is the first sweep. You know what, this is a little bit too much. So let's just stick to the second diagram. Okay, so here we have refreshed positioned icons. And before we do that, oh goodness, this is a lot of text. Yeah, let's try to understand what's going on. So positioned icon. Let's do this. Just for now, I'm going to reduce the font size so I can see everything in one line. So apologies if this is a little bit harder to read. So the first sweep indicates that, the first sweep of the new algorithm XYZ, or the new function XYZ, indicates that we start with icon number 6, which in itself is reassuring. We start with icon number 3, and then we move on to 6. We render A, which is the first dependent. Then we should render A1, or not render, choose A1. And we know that we're choosing and appending the right icons, but we also know that we do it unnecessarily many times. So the next one is 8, which is the end. Interesting. And then we get a B, which is on the level of icon 8. Yeah, that is correct. So where do we go wrong? Where do we introduce the duplication? Then we get 4. And 9. And technically, this is where it should all stop. But we go with 0 again. One, 2. It's not looking incorrect. Here we should expect 3. And we do get 3. Then 5 prime. Then 5. Then 5a. Then 8. Okay. And now it looks like we've appended new dependents twice, which is interesting. Where do we do that? Refresh positioned icons. This is bizarre. Let's just double check that this list is exactly the same as this one. Looks to be 4, and the last one is 9. So it looks like one of these is not necessary. What happened? What would happen if we just do empty? we start with 6. Then we go to 9. So we only return the new ones. Interesting. So this is not wrong. I think what we should do is not to return it here, but instead to do it here. Positioned icons plus plus. Now it should work. Looks much better. I'm expecting to see the whole graph rendered and the lines to be of uniform width, and they are. This thing, same. Okay, let's just triple check. This is going to be fun. Let's just triple check if we don't duplicate any positioned icons. I don't think we do, but better safe than sorry. 0, 1, 2, 3, 5 prime, should be 5, 5, next should be 5a, next should be 8, finally 6, then a, then a1, Okay, looks like it works. Oh my goodness. So we have the new algorithm working, and it's working recursively, which is lovely stuff. This we can clean up even further, which will probably make the subject of our next session. But I'm so happy that the new implementation was pretty easy to code, I think. It's pretty easy to grasp and pretty easy to troubleshoot, because it gave us a number of problems and we did resolve it pretty quickly. So this is pretty good. All right, I think that's it for today. I thank you for your patience and for sticking with me. Next session is probably going to be devoted entirely to cleaning this code up, removing unnecessary code, and applying the suggestions from GHC and HLint, but it should be relatively pleasant and straightforward. I am delighted with our progress this week. We've replaced the layout algorithm yet again. And yeah, very excited for what the future holds. And after the next session, we'll probably go back to real life diagram number 1. We'll try to add pieces to it. And yeah, let's see where this takes us. I've already learned about the type of diagram called silhouette. And silhouette is just your regular basic diagram, but surrounded with addresses and headlines. But I'm sure we'll resolve all of that. I'm having a lot of fun writing this renderer, and yeah, I hope you stick with me for the process. It's a little bit challenging, but fun nevertheless. I wish you a fantastic weekend and see you during the next one.